So architecture of a regression neural network. So we have seen that in the neural network we have three layers. One is called as input layer, input layer, input layer. We have neurons in the input layer, and these neurons are equal to the number of features of the given data point, right? Then we have hidden layers here. In hidden layers, we have many layers, or depending on the problem, we have layers ranging from 1 to unlimited. You can have any number, 1 to any number you can have. So these are hidden layers. The input layer, only one layer. The hidden layers, you can have many. And then the output layer, again, only one output layer. So in each layer, we have the neurons, right? Here in hidden layer also, the neurons may vary in each of these layers, right? This layer may have, let's say, 10 neurons, this may have 5 neurons, right? So the neurons may vary in each of the hidden layer. And again, the output layer neuron depends on what is your output size, right? So we have layers in the input, we have layers input, hidden, and output layer. In the input layer, we have neurons which are equal to the number of features, and in the output layer, the neurons are equal to what is the output, right? So let's see these things, right, in our housing price prediction problem. So if we see here in this problem, in housing price prediction problem, we have three features, right? Number of bedrooms, number of bathrooms, and number of car parkings, right? So there are three features here. So that's why the input layer neurons, the number of neurons in the input layer are three. So the number of neurons is called as shape, right? So input layer shape is equal to the number of features, right? Then hidden layers, number of hidden layers they are really problem specific. We have minimum one, and then we have maximum unlimited. So we can adjust, right? For example, if I start while designing my neural network, I'll start with only one hidden layer, right? Then if my neural network is not getting trained properly, if I'm not getting desired accuracy, right, then I can change these, adjust this number of hidden layers, right? I'll then try with two hidden layers. Then if I'm not getting proper output, then I'll try with three hidden layers, right? That means I can change the hidden layers. I can tune the hidden layers. So that's why they are. This is called as hyperparameter, right? The parameters we adjust, right? In order to get the better results, they are called as hyperparameters. So hidden layer is one, number of hidden layers is one hyperparameter. So neurons per hidden layer, right? Again, in the hidden layer one, I can start with, let's say, only one neuron maybe, right? Or maybe 10 neurons, right? But if I'm not getting the proper output, I can change the number of neurons in the hidden layers. Each of the hidden layers, I can change those number of neurons. So that's why number of neurons in per hidden layer, they are also hyperparameter, right? So they generally are ranging from 10 to 100, right? So these both things are hyperparameters. That means we can adjust those, right? Now output layer shape, that means number of neurons in the output layer. This is same as desired prediction shape, right? For example, the desired output is the single number here, right? In our case, the desired output is single number. That means the number of neurons in the output layer should be 1, right? So because the housing price prediction problem says what is the price of the house, right? So that's the single number, single output we are getting, right? So that's why we will require only one neuron in the output layer. So the output layer shape is 1. Now we have also seen that in each of these neurons we have something called as activation function, right? So this activation function we have already discussed in the theoretical section. So each of the neuron has activation function, right? So that activation function we have to decide. So hidden activation, right? Usually we use ReLU activation, rectified linear unit. So activation function in the hidden layers is ReLU. Usually we use ReLU here, right? And then the activation function in the output is sometimes we don't require it, or we can have ReLU, or we can have logistic activation function, or we can have tanh activation function, right? So these are different activation functions. Then the loss function we have to decide, right? In the last video or the first video of this section, we have discussed that what is a loss. Loss means difference between the predicted output and the actual output, right? So we have seen two types of losses: mean square error and mean absolute error, right? Loss or error. Error means the difference between desired and predicted output and actual output. The difference between predicted output and the actual output is called as loss, right? So we have seen these two types of losses or errors. So we have to decide the loss function for each of the layer, right? Then the optimizer, we have to decide what is the optimizer, how your network is going to train, right? So there are two types of optimizers we normally use. The first is called as stochastic gradient descent, and the other is called as Adam, right? So these activation functions, loss function, optimizer, then the number of hidden layers and the number of neurons per hidden layer, they can vary, right? So what is fixed? So fixed is this input. If I show you, this is fixed. It depends on the number of features, and this is also fixed output layer. It depends on the desired output, right? So only these two are fixed, right? Others we can change. I can change this, right? Sometimes I can have only one hidden layer. I can have two hidden layers, right? Then also I can change the number of neurons in the hidden layer. I can change the activation function, right? I can change the output activation, right? I can change the loss function. I can change the optimizer. Sometimes I can go with SGD. Other time I can go with Adam, right? So that's why these are called as hyperparameters, right? The parameters which we can change, all right? So these are called as hyperparameters, and getting the desired for getting the desired result, we will have the parameters will change the parameters, and changing parameters is called as changing hyperparameters is called as hyperparameter tuning, right? Okay, so this is typical. This is what typically we'll have in the architecture of a regression neural network.